All right, so this is the fourth and final video of the midterm 1 review, and we're gonna look at chapter 4. I was in the middle of videoing something on this, and something happened on my computer. So I already have some of the answers down, and I'm just gonna explain them, but sorry, I'm not gonna kind of go through some of them, and then we'll just pick back up. So the first problem in chapter 4 on the review says to look at this problem, and it says that some people own an iPad, and some do not. And we need to choose 2 people and think about the number of combinations of choosing 2. And so we have 2 people that own them, one owns and doesn't, or the reverse, or that they both do not own them. And so that ends up giving us 4 combinations here, 1, 2, 3, and 4. 4.9 has us look at the exact same scenario, but they want us to list all outcomes and look at complex or not complex. So part A says one of them owns and the other does not. That doesn't imply order. So I'm going to look at both of these. One owns and the other does not. So that would be a complex outcome because there's 2 different ways we could look at that. On part B and part C, these are very similar. At least one or not more than one. Both of those would also be complex situations. On part D, though, it has order here. It says the first one owns and the second one does not. And since it's just that one outcome, first owns, second does not, that's a simple event here. The next set of problems is actually pretty straightforward as far as probability is concerned. There's a hat and there's 40 marbles in it. And some are red and some are green, which I think is really interesting because if you're colorblind, one of the things that you can't see is the difference between red and green because they're opposites. And it's really interesting that that's the numbers, the colors that they chose. But all you need to do to find these probabilities is just take the frequency over the total, and you just use like a relative frequency here in order to create the probability distribution of that hat. All right, and then this is the problem that, oh, sorry, no, this one's still pretty straightforward. So there's 400 large companies here on problem 4.25. 130 offer free health and fitness centers, which means 270 do not. And I found that by I took 400 and I subtracted 130. So if I want to find the probability that they offer these health and fitness centers, I'm going to do 130 out of 400. Do not offer, 270 out of 400. And then part C was like, hey, do these add to 1? And they do because there's only 2 outcomes. Either they offer it or they don't. 2 outcomes only, 2 probabilities, they should add to 1. Okay. All right, and then here was the problem that I was working when my computer decided just to shut down. So it gave us this information about incomes for 500 families. Okay, 50 less than 40, 180 between, and then the rest are 80,000 plus. And it said to go ahead and make a frequency diagram in the question. So 0 to 40,000, 40,000 to 80,000, I just got those here. And I know I need my total to add up to 500. So I'm going to find that by saying, okay, well, what's 500 minus 50 minus 180? And that means that 270 are in this bin here. Part B then said find the relative frequency. Well, 50 out of 500 is going to give me 0.1. 180 out of 500 is going to give me 0.36. And remember, these all have to add to 1 because these have to be all the outcomes. And let's just check. 270 out of 500 would be 0.54. I then can use this table to answer probability questions. Like, what's the probability somebody made $40,000 or less? Well, that's 10% because I'm looking just at this output right here. 80,000 or more, that's 54% because I'm looking at this outcome in my table right here. Okay. All right, continuing with this talk of probability, let's look at a joint frequency table here. So in this joint frequency table, it's men and women, ice cream, C is for chocolate, V is for vanilla, and this is other. Now, one of the things that this table does not give me is the marginal frequencies here. So I'm going to add those. So get 207, 222, and if I add that to 207, I have 400. Oh, just kidding. I forgot I had a third column here. Okay, I'm going to add 271. Okay, now if I add that all three together, I have 700 people here. Okay, and let's just double check. If I add across for men, I get 300. And if I add across for women, I get 400. Yep, so 700 both ways. Good. All right, so on part A, if I want to know what's the probability I randomly choose somebody and they get chocolate, okay, as their favorite ice cream flavor. Well, that's going to be everybody who likes chocolate over the total. Randomly chosen person is a woman. Well, that is all the women out of the total. Probability of vanilla given the person is a woman. Now, in this case, I don't care about my men data any longer because it says given a woman. So I only care about now my women denominator. And so vanilla given woman, I'm going to use this right here to find that. Similarly with man given chocolate, I now only care about my chocolate total. And so man given chocolate is 98 out of 207. Now, are men and vanilla mutually exclusive? And that is not true because an intersection exists. In order for two events to be mutually exclusive, they can't have a joint probability. And there is a joint probability here. Probability of man and vanilla is not equal to 0. So it's not mutually exclusive. Whereas here, you can't have somebody that said chocolate and vanilla. Okay, that joint frequency does not exist. So in this case, those two are mutually exclusive. Now, if I want to think about independence, independence is actually something completely different. Independence is, does it matter that you're a woman that you like chocolate? Okay, and does it matter if you're a man that you like vanilla? Okay, and so how we're going to check that is I want to make sure that is this proportion here the same as this proportion here. Because if it is, then it doesn't matter that you're in that category first, okay? Your proportion's the same no matter what. So is the probability of woman, is that the same as the probability of woman given you're in the chocolate category? Well, that's going to be 400 out of 700. Is that equal to 109 out of 207? So this is 0.57. Is that equal to 0.53? So these are not independent because they are not equal to each other. Okay. All right, looking at our time here on our video, I want us to skip down to 453 here. So on 453, okay, I want to know what's the probability of yes and woman. And this was something about yes, no, and then like no opinion, which I just used this symbol here. So if I want to look at the probability of yes and woman, I need to look at the joint frequency. Okay, and so that's going to be 106 out of our total here, which I need to find that. So 74 plus 106. Okay, here are my totals. So 180, 292, and 128. And if I add, across, okay, 300 and 300. Okay, and I get 600 both ways. Okay, so that's my total here. Okay, no opinion and Mann. And my joint frequency table would be 58 out of 600 right here. Okay, for the ice cream data that we had up above, just to kind of go back through that, Mann and vanilla would be 79 out of 700. Other and woman would be 148 out of 700. You have to make sure that they quantify both. Anytime that's the and, it's the joint probability, and it has to be in both of those. It's like in the cross section of the two. Okay. All right, let's talk about the difference between a problem like 457 and 461 because they look very similar, but there's something that's a key piece here. Now, it depends on how big you are sampling from as to how you're going to calculate this. For example, 8 is not a lot of people. So the probability that the first one selected is a woman, okay, sorry, let's go back. Companies to hire 2 new employees. 5 out of the 8 are women. What's the probability of both are women? So the first one selected would be 5 out of 8. Now the next one selected, it does matter that the first one that selected was a woman because our sample size is so small. Okay, so you do have to change your fraction here. Whereas in 461, it doesn't really give us a sample size, and like the population of adults is so large that it really doesn't matter if you had take one away. It's almost as if you didn't really change anything because the population's so large. Like if you had 1 million people and you took one away, it really doesn't make a difference that there's now 999,999. Okay, so in this case, the probability that all 3 agree, our proportion, we're not going to worry about our proportion changing because our population is so big that we're changing from, or that we're taking people from, since it's all these adults, that it doesn't really matter, or none agree. Okay, so still multiplying, but what you're multiplying matters based again on the sample size. Okay, based on the sample size. All right, there's 2 more questions I want to go over with you, and they're both these down here on the bottom. Okay, so 473. If I want no or female on this online shopping question right here, well, the first thing I need to do is I need to add these, and I don't need my calculator for that. I can just do that. So 800, 1200, 1200, 800, and so my sample size is 2000. Okay, so if I add up no or female, well, no, this 1200 here is this 700 plus this 500. So if I say 1200 plus, and then female, plus 800, what ends up happening is I counted this 500 twice. I counted it once in my 1200 and I counted it once in my 800. So I have to subtract that piece out. Okay, so 1200 plus 800 minus 500, and then again we're going to divide that by 2000, and we get 75%. Okay, let's look at part B here. Male or yes. So if it's male or yes, well, male, 1200, write it over here so I have I kind of ran over there. 12. Or yes. So yes was this. But then I'm subtracting out. Okay, so male or yes. Subtracting out that piece there. Which is also going to give me 75%. Now, C is kind of silly. Yes or no? Well, that's everybody. That was the only two choices that were given. And again, those are mutually exclusive, so we don't have to worry about any overlap because you're either yes or you're no. So that's going to be 2,000 out of 2,000. All right, the last problem in this review video we're going to go over is this problem here, 4.75. Okay, there's free but illegal parking by a sports arena. The probability that you get a ticket is 0.35. The probability you get vandalized is 0.15, and both is 10. So again, if I were to just add up those two pieces, I counted the joint probability, I counted that twice. So I need to subtract that out once. And there's a visual that I like to use with this for a Venn diagram. So this is probability of ticket. This is probability of vandalize. Okay, 35% is this whole circle. 15% is this whole circle. And 10% lives in here. So if you add 35 and 15, you counted that middle part twice. So you need to subtract it out just once in order to get that 40%. Okay. And those are the review questions for chapter 4.